Okay, so this is the briefing for the esterification experiment. So what you're doing in this experiment, as you can see in the scheme, is you're taking benzoic acid. You'll have methanol as the solvent, but it's also a reagent in the reaction as well. Using some acid, this will catalyze an esterification process to give you methyl ester. Now this reaction is reversible, that's why we've got the equilibrium arrows, but because you're using methanol as a solvent, it's in large excess, it drives the equilibrium towards ester formation. So the purpose of this experiment is to give you practice of performing these laboratory skills, sort of safe working practice in the lab, heating a reaction under reflux, IR spectroscopy, and if you haven't practiced these skills before, then this will teach you how to perform a liquid-liquid extraction and a distillation as well. So I'll explain a little bit more about how these two techniques work. To help you understand how to perform these techniques properly, then we have some lab videos for you to watch. So do watch them before you, after you've watched this briefing video. They'll ensure that you are more successful in the lab, because you'll watch them in action and you'll have a better idea of what you need to do. Okay, so I'm going to explain what happens in liquid-liquid extractions generally, but also how this one works for this specific experiment. So what you do in a liquid-liquid extraction is you take your reaction mixture, and your reaction mixture could contain sort of products, your starting materials, the reagents that you're using, and it's a way of isolating the product that you want. What you do is you add some organic solvent, an aqueous solvent that could be water, or it could be sort of an aqueous acidic solution, or an aqueous basic solution. So for an acidic solution, maybe sort of 2 molar HCl. For a basic solution, maybe saturated bicarbonate solution, and it works on the principle that neutral organic molecules will dissolve in the organic solvent, which will be in one layer, and any salts that you have, any inorganic compounds, will go into the aqueous layer. And so if you have two solvents like water, or aqueous solvents and organic solvents that don't mix together, the respective components will go into the layers that they prefer to dissolve in, and then you just run the tap at the bottom. You have a conical flask at the bottom of this separating funnel. You can run down the bottom layer, and then when you get to the point where the aqueous and the organic layer meets, you can close the tap, okay, and then remove that conical flask. Then in a new conical flask, you can then run off the organic solvent. So then you can actually separate compounds from your reaction mixture into different solvents, and it's a way of purifying your reaction. And so in this particular experiment, what you have is your ester product. You might have some benzoic acid that's left over, and you've got some sulfuric acid. So if you have as your aqueous layer saturated bicarbonate solution, which is basic, it's at pH 10, then what's going to happen is the bicarbonate is going to deprotonate any leftover benzoic acid. That's going to turn it into the salt form, and so then rather than benzoic acid dissolving in the organic layer, it's going to dissolve in the aqueous layer. And then any leftover, any acid catalyst that you'll have will also react with the bicarbonate and will sort of neutralize and form carbon dioxide as a byproduct. So what you'll actually do in this particular liquid-liquid extraction is you'll add your layers, you'll put a stopper on top of the separating funnel, then you'll shake and mix all the layers up together, and you're helping this reaction occur, the deprotonation of benzoic acid and the neutralization of sulfuric acid, and then you'll sort of open the tap as you're shaking the set funnel upside down, just to release the pressure of the carbon dioxide that's been generated. Okay, so that's the liquid-liquid extraction. That's how it works. So do bear in mind that while you're doing this sort of separation, you're separating neutral organic molecules from molecules that can be in salt form and can be removed in the aqueous layer. And then for the purification of this reaction, you'll be using a distillation. So the reason you're using a distillation is because your product is an oil, and so you're after the liquid-liquid extraction, the crude product you'll obtain will be sort of probably like a yellowy sort of oil. Your product is a colourless oil, and so what you're going to do is you're going to heat your sample in a distillation apparatus. So you've got your crude product in the flask here. You'll heat it with a Bunsen burner, and then this will boil your sort of ester, okay, and then it will pass through into a condenser. Do make sure you set up your condenser in a similar way with the water tubing that you would do with a reflux. So water goes in through the bottom of the condenser and comes out through the top, and then the vapours of the ester will then condense into the condenser and then run into this new flask, leaving behind any impurities that you have. Okay, and so general principle then, if you've got a solid impurity, then you can use recrystallization. If you've got an oil, then you use a distillation. Okay, so this is a summary of the kind of structure of the experiment. So what you'll be doing is you'll be heating the reaction under reflux for about an hour, and then you'll perform the liquid-liquid extraction and workup process. And so this will take approximately 3 hours, although you might need a little bit longer to finish the full workup process and end up with your crude product. But that's not a problem. We've timetabled that for students who need to take longer. And then the next sort of part is to do the distillation to get your pure product, and then do your analysis with an IR. So just some tips. These are really good tips to sort of follow from the liquid-liquid extraction. So make sure you keep all your layers in your conical flask. So don't actually pour away the contents of your conical flask until you kind of know that you've got either your crude sample or you've got your final product at the end. And actually it's also good practice to label your conical flasks with, this is which ones are the organic layer and which ones are the inorganic layer, because often when you see them, they're sort of they're transparent colorless solutions, and you can forget which one is which. And then for the distillation, avoid heating the distillate too vigorously. So don't just leave the Bunsen burner there, because if it boils really strongly, then you're actually going to bump and boil over not only your product, but actually the impurities as well, if it bubbles too vigorously. So I go back to the diagram. If it bubbles really vigorously and you start spilling over some of the impurities into the condenser, then it's all going to run off into your final product. So what you're better off doing is when you're holding, maybe gently flick on and flick off the Bunsen burner, so the heat goes on and off gently, and that will ensure that you're heating your distillate more gently as well. Okay, so that's the briefing for the esterification experiment.